Howdy, it's TUBALCAIN once again, and this is Machine Shop Tips number 306 entitled Fabricating a Belt Guard for a South Bend 9-inch lathe. And this is the little lathe that followed me home, so if you haven't seen that video, feel free to do as so. And in the previous video, number 305, I showed how to remove these two pulleys, but the subject of this several part video is going to be fabricating a belt guard that will be two-sided, so there's just no way that I or anyone else can get my fingers in there. And looking back at this 1948 ad for South Bend lathes again, you'll clearly see that there is no belt guard and never was a belt guard. But I think with the later Model A lathes that they made perhaps in the 70s or even 80s, there was a cast iron one-sided guard. It's a pretty guard, but whether or not it would fit this lathe, I do not know. And I intend to make this, this guard large enough such that it will accommodate this belt in the outer large pulley here, which I very seldom use. In fact, most of the time, this would be on that step. But I want to make it so that I can use either step. Be sure and unplug or cut the power to your lathe when you work on the drive line. Now let's take a look real briefly at a previous video I made on the Logan lathe. This will just take a minute and then we'll get back to the business at hand. If you follow my videos, you probably saw the recent videos. There were two of them, numbers 296 and 297, where I fabricated this single-sided belt guard for this Logan 10-inch Powercraft lathe. Take a look at that if you haven't seen it. And the reason I'm showing you this is my critics immediately said, well, you can get your fingers caught in these belts, pulleys from this side, and I guess you can. So that's why I'm going to make a two-sided belt guard for the South Bend lathe where absolutely nobody can be hurt. But you know, you really can't make anything foolproof because fools are so ingenious. The first thing I'll do is take the belt off, and it needs a new belt, by the way. It may not get one. That's a B belt. Now these of course are going to come right off, and I show how to use pullers. Now I need to measure for it, and this pattern here, and I need to make another pattern because this one isn't going to work, but I'm going to make another pattern, and it will have the same dimensions between the center holes, but it needs to be a little bit larger in diameter to accommodate the belt riding over this pulley. The bottom can be about the same. So let me lay that out on cardboard, and then I'm going to, which may not be necessary, it could be done directly on the steel. I'm using 14 gauge steel. But this backing plate will be fastened here, and I haven't decided yet how, permanently. And then the sides welded onto that, and then there'll be a front cover without any holes in it that'll be hinged to open it up for changing the belt. So that's the game plan. The large pulley with the belt wrapped around it comes to 11 inches approximately. So I'm going to make the guard 12 inches. I want plenty of room there, and it's not very critical. And the small belt pulley is 3.5. So I'm arbitrarily making the bottom 5 inches. So this is the pattern, although this isn't to scale, and I should make a drawing, but I guess this is my drawing. But the center to center distance, center to center, over on the lathe is 12.25 inches. So I will locate those on the stock and then swing the arcs, the semicircle, and these lines will be drawn tangent to the circles. And these holes, remember, this is the inner plate. These holes need to be about 1¼ inch, again, not too critical. I think I'll make them both the same, and I'm going to use a hole saw for that. Let's go down in the basement where I have my proper layout tools, and I'll do that layout. Now the layout is going to be very similar to the front cover as well, although I may just trace that so I have an exact fit. But that's a couple days down the line. I will work on this over about a 1-week period. This is a sheet of hot roll steel, 12 gauge, which is 109 thousandths thick. And it's just a piece that I had around here. In fact, this was the stand for my Vespa motor scooter when I bought it. Just a little rack that would hold it upright to work on. So that's what the grinding marks are, where I had to take a few welds off. But in fact, oh, for your information, the Vespa is history. I realize I'm never going to get it done, so now the Vespa resides in Indianapolis, Indiana. So it went back home to Indiana. And there's plenty of room on here, not this way, but this way, for 2 of them, and I will nest them approximately like that. So I'll get started now with the layout. Alright, let's start the layout on this corner, and again, this is hot roll steel, and you can tell by the bluish or blackish color on it. There's a bit of a scale, and that scale is hard, and you need a sharp scriber to really go through it. This happens to be a carbide scriber. This is set for 6 1/4. And then from this way, 6 inches. It's quite a luxury to have all the duplicates of tools that I have here. That's, again, 6 inches. Take the big old Starrett. Center punch. Somebody put a rubber cork on there. It sure was nice. That wasn't me, but it was a good idea, whoever did it. Someone that is long, long dead. I've set this Craftsman dividers for 6 inches. Now the reason for that is I want this edge of the material to be one edge of the guard. So that's one less very long saw cut that I have to make. So I'm going to swing an arc, but in fact I'm going to swing a circle all the way around, just so you understand what I'm doing. And that isn't going to show up very well. And this scriber is not, or this divider is not all that sharp. I'd probably be better off using a pencil. For the benefit of the camera and the video and all of you viewers out there, I'm going to redo this with this old Starrett wing divider here with a sharp pencil in it, because at least it'll show up better. Although certainly a wide pencil line isn't as accurate, but then again, we got to remember that this is just a sheet metal guard. That shows up a lot better, I think. Now I'm using a trammel point, and it's set at 6 1/4 from a longer ruler than this, and pay no attention to the ruler that it's on, because that's strictly a beam, could be anything. And from this center hole up here, I'm swinging an arc. Got some interference down there. Just swinging an arc. I'm changing a dimension from 5 inches to 4 1/2. So the radius of 4 1/2 is 2 1/4. This combination square is set for 2 1/4. Now on the arc that I just swung, coming in from the edge, $2 1/4, and marking it. and I'll center punch that. From the center punch mark now, the divider is set at 2.5, or 2 1/4 rather, which gives me a circle that is 4.5. Yeah, that pencil is showing up much better. And now all that's left to do is to lay a line tangent with the two circles. Remember what tangent means, it's just a line that comes right to the edge of a circle. So using a long straight edge on my carbide scriber, that's right on the edge of the circle. I'll swing this back and forth here, and I'm looking at the edge of the circle up here, which may not show up too well on the camera in the video, and then holding it very tightly like that so that the straight edge doesn't move. I've drawn a line, and so now whether you can see it or not, follow the line now. Can't follow it myself. Right there. And I don't have to do anything here. See, this side is done. Now over to the bandsaw. Well, one more thing. I'm going to go ahead, although this could be done at any time, and lay out some small circles here. Remember, they're going to be 1 1/4 inches. That's optional, but I think I'll go ahead and do that at least with a pencil. This is a rather large and clumsy piece to feed through the bandsaw at this time, but I'll do the best that I can. It's a lot of cutting, but I'm making some progress. It's getting there. Just have the final radius to saw off at the bottom, and then dress it up on the belt sander. That took at least a half hour to saw that out, and now it's a little bit rough. I will sand it down to the line. At this point on the 6-inch Delta belt sander, I'll just grind the sides down and blend it all in and smooth it up and remove the saw marks. And so on. That belt sander really blended in nice, and I took a file and knocked off any sanding burrs. Then I drilled a 1/4 inch hole here and here, and those are the pilot holes for the 1 1/4 inch hole saw, which I'm going to use here momentarily. I won't show that because I showed that in the previous video. And why did I pre-drill these? Because there's a 1/4 inch pilot included with the hole saw. Just easier for me. And then I put a board or something, some scrap wood under it. And plenty of Earl. I already drilled one big 1 1/4 inch hole, and I do not recommend drilling real large holes on a drill press because the slowest speed on this one is about 500 RPM. If you recall in the other video, I used the Bridgeport mill, and this will work for an 1 1/4 inch, but I tell you what, it's pushing the envelope. And When I do this, I like to notice there's wood underneath here. I like to drill about halfway from each side so you don't get those horrendous burrs, although there'll still be a burr. And I like to use oil liberally. As you can see, a little drill press like this doesn't even begin to have the torque necessary, but it's going to do the job. As long as you've got a sharp saw. If you've got dull saws, throw them out. They are absolutely worthless and cannot be sharpened. Chips there so you know it's hot. Success. I'm back, and this is day 2 of the build. Be sure and watch the first part if you haven't. And this is ready to go on, or to fit up, to see how it fits. And in order to center this thing, while I fabricate it and lay it up and all of that, I made a couple of Delrin bushings. And maybe I wasted my time, I don't know. That just centers it for me, and I ran into just a little problem on the other one for the Logan. Without that, it was a little bit harder to center it. But that's the general gist now of the way it's going to go. And then, of course, the pulleys go on here and here. And the next thing I want to do, and I am going to clean this all up, at least this portion of the lathe, and that's about a day's work in itself. And I need to rewire the motor. I've already put a new cord from the switch to the outlet, but I want to change the other cord and put a grounded cord on. This is grounded, the other one, the old one was not. And next, I think I'm going to go and try to figure out how to fasten this on. So let's see how I'm going to do that. I just drilled a 1/4-inch hole. I took this over to the drill press in order to do that. And I think you can see my plumb line here with a magic marker that is really on the center line of this shaft. And then I determined the height from looking behind where I want it to be drilled into the cast iron. And I will open this hole up to 5/16 here in a few minutes. But right now I'm going to drill right through this hole. And that'll give me the alignment that I want. And I'm going to drill the 1/4-inch hole right into the cast iron as straight as I can, freehand. And then I will tap it 5/16, 18, and then re-drill the hole in the guard 5/16. This will be easy drilling because it's cast iron. I am now tapping this 1/4-inch hole 5/16, 18, that's coarse, and notice I selected a spot on the casting that is hollow. I do not want to deal with a blind hole if possible, and I'm trying to tap as straight as I can. As well as it is possible freehand. That's a taper tap, so I have to go in a little extra deep to overcome the tapered teeth on the end. I have a temporary bolt in here just to hold it into position, and I've brought the entire back of the guard here into plumb with this little cheap magnetic level. And looking at it from the back side now, you'll see that I have to change the spacing because of this hub here on the wheel will have to be set way back into the guard. So I have to open this hole up, and I'm going to do that a little later on, and throw the white thing away here. But let me move the camera to the back side and show you what's going on back there. Now I'm at the back side, but remember, I don't work from a drawing, and there's all kinds of interferences and different things like that will happen when you don't draw it out in 3 views, and I expect that to happen, but that's just kind of the way I work. But the bolt that I just mounted here, and here's the hole that I drilled and tapped right here, but I have temporarily put a couple of 3/8 nuts just as spacers over the 5/16 bolt. And I will later determine what the length of that needs to be, but it has to be much shorter than it is now in order for the guard to come up over this bearing here at about the point of where the screwdriver ends. That's how far I want it to come in. Also, there has to be another fastener or bracket or something of some kind right in here. That's also to be determined later on, because we know that's not going to be tight enough, although I don't have this bolt tight either, and I'm just fitting things up. But I don't want to do any of that until I set up my welder and I got my bending and fabricating going on, and that's a couple days away, so that's why I'm going to put that off. And what I intend to do now is take this off, set it aside for the time being, and totally clean up, and I might even paint this entire casting here. It is filthy dirty from chips and dust and grime and corruption from 60 years, as well as materials from the belts that has flaked off. So this is so dirty that I really want to just take the whole thing off and deal with it that way, but the motor has to come off first. Off comes the flat belt. And just a reminder here that when I mount this guard, that everything must be mounted to the bracket here rather than onto the bench itself, because this whole unit has to be free to swing to tighten and loosen the belt. And then what I'm going to do here, and make sure when you cut a wire that you do not have a live wire. As you know, I go to many auctions, garage sales, and so on, and about half of all of the nippers and wire cutters that I run across have a big hole blown into the jaws from somebody cutting a hot wire. So that's free to come off now. Now I'll unbolt the filthy motor. I'm going to make some scribe lines on there such that I can return it into the exact same position. It's a capacitor start. I believe it's half horse. I haven't really looked at the nameplate, which is on the other side. There's the filthy Westinghouse motor, and you know what, I changed my mind and I had a burst of energy, and I've taken this bracket off, but notice, if you will, or can, that I scribed clear around the outside of it so that I would have the location. And it's just as dirty as I thought it would be, and into a pan of solvent it goes. This is K1 white kerosene. At least it was white a couple of minutes ago. Not bad on the bottom side, as you would expect. You know, it's not bad at all cleaning something like this up when it's off of the machine. And you can start to see the original color here of the South Bend lathe, and I know I'm not going to be able to duplicate it. The color, that is. You know what? That wasn't a half bad job. It's really only 10 minutes later. It's totally clean, and then I took it down into the basement and I scrubbed it with very hot soapy water, and a brush, and it's still warm for that matter. And that also helps it to dry fast when you get it hot like that. So other than painting, this casting is ready to go. Now I'll start on this part, and it's quite awkward because it doesn't fit in the pan. I won't show all of that, but that's the general way that I'm doing my cleanup. And if school was still in session and it just let out here, I would go down to the high school and use their big Gray Mills parts washer. I know that Dan would let me use it, and but school just got out and I missed it by 2 days.